All right, so it says sketch the graph of the given function, state the domain of the function, identify any intercepts, and test for symmetry. Is the function even, odd, or neither? Well, sketching the graph, all you need to do is create your XY table. Plug in values for x, like 0, 1. I don't know why it does that, but it does it, like 0, 1, 2. Now, if it doesn't give you enough information, plug in more, right? You want to plug in enough values to where it gives you the information you need. So if I plug in 0, 2 minus 0, you get 2. If I plug in 1, 2 minus 1, I get 1. If I plug in 2, 2 minus 2, you get 0. So x is 0, y is 2, 1, 1, 2, 0. The domain, right, if we look at it, is anything inside of a square root? No. Am I dividing by x? No. So my domain is negative infinity to positive infinity. Identify any intercepts. My y-intercept is here. So my x-intercept is 2, 0. My y-intercept is 0, 2. And then determine symmetry. So if it's symmetric over the y-axis, right, we call that an even function. So you have to show that this statement is true for it to be even. So does your original function, does that equal the same as if I plugged in a negative x? Those the same? No, not even. Now we need to take a look to see if it's odd. So to show if it's odd, that's does f of negative x equal negative f of x. You have to show that that is true. So you plug in, well, the one with the negative x plugged in, that's already done. We can just use it. But then negative times your function. Are those the same? No. So it's not odd, therefore it's neither. For this one right here, create your table. I picked 0, 1, and 2. Plug in 0, plug in 1, plug in 2. Start graphing it. 0, 1, 2, 8. Okay, that's kind of doing something weird. I don't really know what's going on with that. So let's try some negative numbers. Negative 1 is negative 1, negative 2 is negative 8. Oh, well, look at that. So it looks like your graph is doing that. So now it says state the domain of the function. Okay, is x inside of a square root? No. Is x being are we dividing by x? No. So there's no restrictions. So your domain is negative infinity to positive infinity. Identify any intercepts. Your x and y intercept is here at 0. 0, 0, 0, 0. Test for symmetry. So we want to see if it's even, odd, or neither. So if it's even, you have to show that this is true. So does your function equal your function with negative x plugged in? Do those equal? No. So now we have to show if it's odd. If it's odd, That's does your function with the negative x plugged in equal a negative times your function. So we need to know if those are even, or if these are true. So your function with a negative plugged in, does that equal a negative times your function? Negative times a negative times a negative is equal? Yes. So therefore, it's odd. For your piecewise functions, to remember, it looks like between 4 and then 5. So this is the square root of x plus 4. That's here. And then this is the square root of x minus 1. So for your xy table, it might help just a little bit. So you're going to pick negative, oh, it's negative 4. Whoops, I read that as positive 4. So ignore that. I can erase. So all of this is the square root of x plus 4. Okay, so you just plug in values, like plug in negative 4. So if I plug in negative 4, I get 0. If I plug in negative 3, negative 3 plus 4 is 1, square root of 1 is 1. You plug in negative 2, you're going to get the square root of negative 2, which, enter that in your calculator, that's 1.41. This is going to be a little bit more, right? And you just plug in values. If I wanted to plug in 0, 0 plus 4, square root of 4 is 2. So it's going to look like that, and then it's going to get cut off there. And then the next one, if we start at 5, so square root of 5 minus 1, that's 2. And then that's going to start here. And then, pick some values like 10. 10 minus 1 is 9, square root of 9 is 3. It looks something like that. This next one, just remember how it's being divided up. Negative 2, positive 2. So this graph is the x squared, 3 minus x, and 4.